All right, as we continue our unit on modeling data, we're going to do a lesson called Connect the Dots, where we create some scatter plots and we'll use technology. I'll show you how to use Desmos to create the correlation coefficient of the linear fit of the data, and as we do that, we'll help develop an understanding of what the correlation coefficient tells us. So what I'd like you to do is take this data. We've got 1, 2, 3, 4, 5, 6, 7 sets of data. And you're going to graph that on a scatter plot and use your graphing calculator to calculate the correlation coefficient. Correlation coefficient is R. Find out what the R value is, and after we do that, we'll kind of figure out, well, what does the R value tell us? So I'm not going to tell you at first. I'd like you to try to figure that out on your own. So you're going to put this data in one by one, calculate the correlation coefficient, and then put the scatter plots in order based on their correlation coefficients, and compare the scatter plot with the correlation coefficient. What patterns do you notice? So in order to do that, you'll need to go into your graphing calculator. If you want to use if you have a TI graphing calculator, I could show you how to do that. But otherwise, you can use Desmos. So let me just quickly show you how to do that on your graphing calculator. You go to Stat and go to Edit, and you'll enter in your information. So this would be my X. So I type in 2, 2.3, 3.3, 3.7, all the way down the line until I get all of my data entered. And once I do that, that's my first column. And then I'll go to my second column, L2, and I'll type in the row below. So this will be L2. This will be L1, line 1. And I'll type all my information in. And then as I do that, next I'm going to create my scatter plot. And looks like I missed some information. Let me figure it out. Okay, good. Got that figured out now. So I got my scatter plot, and then I will go to make sure my stat plot's on, so second stat plot. Turn that on. Got to make sure that I have scatter plot chosen. I had box plot chosen. Scatter plot X list is L1, Y list is L2. So I'll go to Zoom. On option 9, Zoom Stat. And that'll create my scatter plot. So I can kind of see that there's positive or negative correlation or no correlation. And then in order to get my R value, go back to Stat and over to Calculate. Go down to Linear Regression. And I will calculate that. And it didn't give me my R value, so I gotta go back into Catalog, go down to Diagnostics. So once I've scrolled all the way down to Diagnostic On, I'll hit Enter. Diagnostic On, Enter. Done. So I go back to Stat, Calculate, Linear Regression, option 4, Enter, and I got my L1, L2 as my X and Y's. Calculate, and now I've got my R value. Here's my A and my B, my slope and my intercept for the regression line that I'm creating. And my R value would be 0.497. So I would write that down on my sheet. My R value is 0.497. And if I want to see the equation that goes along with that, I go to Y equals. There's statistics. Since it's stored in my calculation for me, go over to equation, regression equation, and then go back to graph. And there's my regression line that goes along with the values that I got with my R value of 0.497, the equation that goes along with it. So that's how to do it on your TI calculator on Desmos. Maybe it's a little bit quicker. But if you open up to Desmos and then if you click up here to open graph, you're going to scroll all the way down through all these created ones already. And near the bottom, you've got statistics, linear regression. You open that one up. And then it's just a matter of entering your scatter plot. So just like we did on our TI calculator. Oops, I type in the same data again. And as I do that, the scatter plot automatically enters. And I just need to make sure that all my values are listed. Go back and change my Y values. And my scatter plot automatically gets created on the screen. And so here's my scatter plot, just like it looked on my TI calculator. And then it creates my regression line automatically because the regression equation is right here. It gives me my slope and my intercept, and then it gives me my correlation coefficient of 0.497. So what you need to do is pause the video and then go through and adjust. We've done set A, so now go through and do B through G, calculate the correlation coefficients, and find out what you notice with those values. What do you notice about those scatter plots? What connection do you see? So take the time to do that, pause the video, restart it when you're ready to go through the questions. So set A we looked at already. Set B, if we look at their values, there's our scatter plot, and I found the R value of 0.935. As we look at set C, those were going down. The R value is negative 0.944. Set D, once again the scatter plot's going down. This R value was negative 0.774. Set E, as we looked at those didn't really going up or down and kind of going across more than anything. R value of 0.07. Set F, those are going up, and as the line that goes through it goes through every single point on there. Our R value was 1. And then with set G, those points were going downhill, and every point is on our regression line. Those had an R value of negative 1. So as we plotted those together, we wanted to keep track of, once again, those are the R values associated with each graph. Put those scatter plots in order based on the correlation coefficient. So I had G, C, D, E, A, B, F, starting with the least, and then working our way up to the largest value. And these are some things I noticed. I noticed the positive R values, the scatter plot was going up. Negative R values, the scatter plot was going down. And the closer I got to 1 or negative 1, the closer that scatter plot resembled a linear model. So those are just things I noticed. Maybe you noticed some other things as well. Now I'd like you to explore some things on 4 through 7. You're going to use the data from set A as a starting point, and keeping the same X values, you need to modify the Y values to obtain a correlation coefficient as close to 0.75 as you can. And then you're going to do the same thing and try to get R values close to 0.25, and try to get one as close to negative 0.5. And then in so doing, answer those questions. What did you have to do with the data to get that value? And then at the end, you're going to describe what that correlation coefficient appears to describe. So in order to do that, you can go back into Desmos, and if you have that set A value still available, all you have to do is just modify your Y values in order to, if you've got an idea of what you think helps that out, and just adjust those Y values. So let's say I'm going to adjust this point here, and I'm just going to change that to 3.7. As I do that, it automatically calculates my R value. Now it's up to 0.621. So try that on your own. See what you can get. I'm not going to show you my values. I just want to see what you can get. I'll show you my values. I'll do that. I'll share. But I'll show you what I get, and then I'd like you to answer these questions on your own. But try it on your own. See how close you can get and then list your values and see what kind of connection you get with that correlation coefficient. So go ahead, start the video when you want to see what values I used. Okay, so let's take a look at the data that I found. Yours is probably a little bit different, but our questions will probably be similar, our answers will be similar. Here's what I did to my table, and in order to get it to 0.75, I adjusted a few of my points on the y's to get them, the y values were lower, I got them higher so that they're closer in line with a linear function going up. You see they're a little bit closer to the equation line. In order to get it closer to 0.25, I scattered these points one way above, one way below, so it's still going positive, but they're further away from the line. And then in order to get it negative 0.5, I knew they had to be going down, but not very close together. Still kind of scattered, some going up, then down, then up. So kind of all over the place still, but they're going down. So that's what I did. And then in order to answer that final question, what aspects of the data does the correlation coefficient appear to describe? Well, it seems if it's positive, those points go up over as we go left to right. If it's negative, they go down. And you can see the closer that number is to 1 or negative 1, the closer those points are to my regression line, my regression equation. 0.75, they're closer. 0.25, they're scattered further away from that line. Negative 0.5, they're a little bit closer to the line, kind of in between 0.25 and 0.75. So that's what that regression, or the R value, tells us. It's that correlation coefficient, which tells us how closely do our points correlate to a linear equation. So you kind of work through that in your homework that you can do in class. So estimating lines of best fit. So you're going to be drawing a line in and kind of estimating a y-intercept and a slope. And then estimating correlation coefficients based off of what we learned today and how close those points are together. And then same here, follow the prompt to sketch a graph of the line with the given characteristics. So reviewing what we know about linear equations. So that's all the time we have. If you have questions, I can help you out with that in class.